10.7 trigonometry unit, reference angles and quadrant signs. In today's Do Now, you're supposed to sketch the angle in standard position, that is 330 degrees, then find the exact value of sine 330 degrees using special right triangles. As you can see, here's 330. This would be a 30, 60, 90 triangle. And based on what we learned in our previous lesson, the longer side, the longer leg, is square root of 3 over 2, which is your x value. And your shorter side is 1/2, and it's going to be negative 1/2 because we are in quadrant 4. So, to answer the question, sine of 330 degrees equals negative 1/2. Okay, reference angles. So, let theta be an angle in standard position. The reference angle for theta is the acute angle, theta prime, formed by the terminal side of theta and the x-axis. The relationship between theta and theta prime is shown below for non-quadrantal angles theta, such that theta is between 90 and 360 degrees, or pi over 2 and 2 pi radians. The thing is, you've already been using reference angles. For example, in yesterday's lesson, in the last lesson, you're basically, for example, if you take this one and you drop down your side of the triangle to make that right triangle, this angle right in here, which I'll highlight green, is your theta prime, is your reference angle. This is your reference angle, okay? So basically, it's always the angle that's nearest the origin formed by dropping down a perpendicular to the x-axis. You can do the same thing here. Right, it'll be this guy there, and over here it'll be this angle there. Okay, and then I'll go ahead and drop down this perpendicular, and we'll drop this perpendicular down here. Okay, now you can figure out what this is just by subtracting 180. You could do 180 minus theta when you're in quadrant 2. Right? When you're in quadrant 3, your angle is going to be greater than 180, so you want to do theta minus 180. And finally over here, when you're in quadrant 4, to figure out what the reference angle is, it's 360 minus theta. Okay, so there's a 3-step process when evaluating trigonometric functions. First step is find the reference angle. All right, we just learned how to do that over here. The second step is to evaluate the trig function for theta prime. Okay, so you want to use theta prime to find the trig function. And the final thing you want to do is figure out the sign that is plus or minus of the trig function based on which quadrant it's in. So as you can see in quadrant 1, we know that x's and y's are all positive. We know that sine of theta is really the y value, so that's positive. Cosine is really the x value, that's positive. And tangent is really sine divided by cosine. So positive divided by positive is positive. They're all positive. In quadrant 2, sine is still positive because we're above the x-axis. Cosine is negative because we're on the left side. And when you divide, plus divided by minus, you end up with minus. In quadrant 3, we know that x's and y's are both negative, so sine is negative, cosine is negative, and tangent, negative divided by negative, is positive. Finally, in quadrant 4, sine is negative because we're under the x-axis, or less than the x-axis. Cosine of theta is positive, and negative divided by positive is negative. Okay, now there's a cool way you can actually memorize this, and we'll highlight. As you can see, all of them are positive in the first quadrant. Sine is positive in the second quadrant. Obviously, so is cosecant, but we're just going to say sine for this little memory trick. In quadrant 3, tangent is positive, and in quadrant 4, cosine is positive. So This is the trick. So the trick is all students take calculus, okay? A stands for all trig functions are positive. S stands for sine is positive. T stands for tangent is positive. And C stands for cosine is positive. So that'll come in handy. Example 1. So here we need to express sine of negative 230 degrees as a positive acute angle. So here's sine of, here's negative 230. Obviously we go clockwise because it's negative. And let's find the coterminal. Coterminal is 130. The reference angle will be the line, the angle that is between this and the x-axis. So we'll find that by saying 180 minus 130. It's 50 degrees. So right in there is 50 degrees. So sine of negative 230 is really sine of 50 degrees. Now, the last thing we need to do is, based on what quadrant we're in, we want to keep sine positive the way it is or change it to negative. And because we're in quadrant 2, sine is positive, so it stays sine 50. All right, here's another one. You do number 2. Sine of 240. Now, it's already positive. We don't need to find the coterminal angle. So we want to find the reference angle. And that will be 240 minus 180 to give us 60 degrees. So we know right in here is 60 degrees, right? That's the reference angle. So sine of 240 is really sine of 60. But the thing is this, we're in quadrant 3, where sine is less than 0, sine is negative. So we need to change sine to negative, and we need to keep 60 the way it was. So negative sine 60 degrees. The answer is that. Okay, so more examples. Sage and scribe number 3. Here we have cotangent of negative 200. It's coterminal of 160. So we're going to subtract 180 minus 160 to get 20. Therefore, cotangent of negative 200 is really cotangent of 20. And we need to check. We're in quadrant 2, and we know cotangent and tangent are negative, so we need to change our answer to negative cotangent 20. The answer is 3. Sage and scribe number 4, reference angle. So we're looking for 230 degrees. Once again, we're in quadrant 3, so the reference angle is 50 degrees. All right, so sine of 230 is really sine of 50 degrees. And we are in quadrant 3, so sine is less than 0, sine is negative. So the answer is negative sine 50. All right, let's take a look at these. These are actually easier. They're saying that if tangent is negative 3, in other words, if tangent is negative, and the sine of x is greater than 0, is positive, what quadrant are we in? Well, we know that sine is positive in quadrant 1 and 2. For tangent to be negative, it has to be talking about quadrant 2, because sine divided by cosine is tangent, and because these divide and you get negative, it must be talking about this quadrant here, because cosine must be negative. Number 6. Cosine of theta is positive. Cosecant of theta is negative. So I interpret this as sine is negative, and this as cosine is positive. So there's a plus sign, minus sign. Which quadrant is that? Right here, quadrant 4. All right, so if sine of theta equals cosine theta, in which quadrants may angle theta terminate? So these are all of the trig functions and their signs. In order for sine and cosine to be equal, let's just look at all of them. They're both positive, that's not it. They're both negative, they're equal, and they're different here. So ladies and gentlemen, the answer is quadrant 1 and quadrant 3. The answer is option 3. Okay, this one here, tangent of theta equals 1 plus radical 3 all over 4. Don't be confused by this one or scared. They're really just saying that tangent is positive. So, where is tangent positive? Tangent is positive in more than one quadrant. In quadrant 1 and in quadrant 3. So the answer to this one is option 1. Good luck to you.